Okay, in this video we're going to talk about ellipses. When we graph an ellipse, we have not just one focus, we have two foci. And so the ellipse is going to be the oval shape. It is possible, we'll kind of lump circles into this as well. So if we have the same amount of stretch on both the x and y axis, then obviously we would have a circle there instead of an ellipse. So that's kind of the same category here. On this front page of the notes, you're going to see a lot of information about an ellipse. The main difference here, you might look at the equations and be like, they look kind of the same. And the difference is this a squared is first here, the b squared is underneath the y, or vice versa. Okay, but the key is that a always has to be greater than b. So what we're looking at is the bigger number underneath x, or is the bigger number underneath y? That's going to determine the orientation of the ellipse. If the bigger number is underneath x, it's going to be a more horizontal ellipse. It's going to be stretched more that direction. If the larger number is underneath y, then we're going to have a more vertical ellipse, and the stretch will be more on that direction. We're just going to follow through all the rest of this information, finding the vertices. Again, not just a singular vertex, but the vertices. Those are going to be the endpoints on the major axis. So the major axis is the one that is stretched more. The vertices being the endpoints of how that is stretched. So if it's horizontal, those will be on the x-axis. If it's vertical, those will be on the y. And then your foci, again, align on that major axis. So they're going to be on the x if it's stretched more horizontally, on the y if it's stretched more vertically. And then we have a formula to find the foci, where we're going to do a squared minus b squared, and then take the square root of that to get that c value. And again, those are going to be just the numbers that we have underneath of x squared and y squared. So again, you're going to want to reference this sheet as you're going through it, but I'm going to go ahead and jump into an example here. Here's an equation of an ellipse. Find the foci, vertices, and length of major minor axes, and then we're going to sketch the graph. I'm actually going to start with sketching the graph because I think that is the easiest thing to do. What I'm going to do is look underneath each variable. I'm going to have a number there. I'm going to take the square root of that number, and that's going to tell me how far out to go in that direction. So in the x direction, I'm going to go out 3 units because of that 9 being 3 squared. So I'm going to go out 3 horizontally each direction. And then vertically, take the square root of 4. I'm going to go 2 each direction. Once I have all of that information, with that, I can actually go ahead and graph the ellipse. And then I'm going to fill in all the information. Okay, so I'm going to do this in a little bit different order here. The vertices are just the endpoints on the major axis. So the major axis is where it's stretched more, which in this case would be the x. So the vertices are going to be plus and minus 3, comma 0. You could write those separately if you want, negative 3, comma 0, and positive 3, comma 0. I'm just going to write it all at once. To find the foci, I've got to use that formula. So the foci formula is c squared equals a squared minus b squared. A squared and b squared are these numbers. Don't square them. Okay, so that's going to be 9 minus 4. It's always bigger number minus smaller number. So c squared is going to be 5. Take the square root. We're going to get c equals plus or minus the square root of 5. The foci are coordinate points, so don't just leave it at that. So what I'm going to do then is say whatever coordinate my vertice was, that's going to be the same coordinate. So my foci are going to be the coordinate points plus or minus the square root of 5, comma 0. That number is rough. It's a little bit larger than 2. So if I were plotting that, I'd go a little bit more than 2 in each direction. It doesn't have to be perfect. And there's one of the foci, and I'll do that to the other direction as well. And there's the other one. Okay. The other things I need to list are the lengths of the major and minor axes. That should be pretty easy. The major axis, all I'm going to do is look and say how long is that line segment, right? From vertex to vertex. I went 3 in each direction, so the major has a length of 6, and the minor has a length of 4 because I went 2 in each direction. And that's it. Okay, so we're going to fill in all that information, make that graph. Number 2, obviously this equation is of a different form than what I have up here. I want to get it to this form, which means I want to get 1 on the right side. I always want it to have equals 1. So in order to do that, I'm going to go through and I'm going to divide everything by 144. That's going to make the right side of the equation 1. And then I'm just going to reduce this fraction here. So 16 over 144 is going to be 1/9. So that means this is going to become x squared over 9 plus 9 over 144 is 1/16. So that's going to become y squared over 16. So now I'm looking at this equation, and then I'm going to go through all of that same information. Okay, so the other information that we have here, vertices, again, I wouldn't even write this down until I go ahead and graph it. So the center of the ellipse is at 0, 0. We're going to go out 3 in the x direction. 1, 2, 3, 1, 2, 3. We're going to go 4 in the y direction. So up to here, down to here. Go ahead and make your ellipse. I can tell that it's stretched more vertically. So that means that the vertices this time are going to be the endpoints on the y because it's stretched more that direction. So this is going to be 0, plus or minus 4. To find the foci, using that formula, c squared equals a squared minus b squared. So c squared is going to equal 16 minus 9, which is going to be 7. We'll take the square root of that. So that means our foci are going to be 0, plus or minus the square root of 7. Again, that's a y-coordinate this time because our major axis is the y. And again, to plot those, that would be somewhere between 2 and 3. So I'm just going to go between 2 and 3 units and list those foci. The length of the major axis is 4 each direction, so that's going to be 8. The length of the minor axis is going to be 3 each direction, so that's going to be 6. Okay, so on to the last question. This time, notice that instead of just x squared and y squared on top, we have transformations. So just like with parabolas, if we have transformations, that's going to adjust where the ellipse is at on the graph. It's not going to be centered at 0, 0. It's now going to be centered somewhere else. So now we're going to be asked to not just find the foci and vertices, we're going to be also asked to find the center. Okay, so the center is going to be the opposite of what's with x, so -1, comma, opposite of what's with y, which is 2. So the point -1, 2 is the center of the ellipse, and I'm going to base everything off of that. So you'll see how that changes what we do in terms of writing our vertices and our foci. What I would do, again, make the graph first. I think that's the easiest thing to do. So in the x direction, I'm going to go out 2 units, both directions because of that 4. In the y direction, I'm going to go 3 units. Go ahead and graph the ellipse. It's stretched more vertically. So our vertices are going to be those coordinate points, right, on the y-axis or on the vertical axis here. You can just list those points. Be like, okay, well, what are those coordinate points? It's -1, 5 and -1, -1. You can absolutely just list it that way. If you're using the chart on the front of the notes, again, we're looking here this time because it's stretched more vertically. And the vertices are 0, plus or minus a. Really what you're doing is you're taking the center and we are adding to that 0, plus or minus what was my y stretch? It was 3. And that's going to give us, for the vertices, that's going to give us -1, and then I can actually just write 2 plus or minus 3. So I'm just adding the x coordinates, -1 plus 0, and I'm adding the y coordinates, 2 plus or minus 3. You can write it that way, or if you would like, again, you can just say, well, that means it's -1, 5 and -1, -1. I don't care how you write that, but that's what you're going to do there. Okay. If you do it this way, it's going to make more sense for when we go to do the foci, because we are probably going to have to leave it of that form when we do the foci. Again, we're going to do c squared equals a squared minus b squared. So c squared equals, that's going to be 9 minus 4. always biggest minus smallest. So c squared is 5. We take the square root. C equals plus or minus the square root of 5. Now again, what's our major axis? It's the y. So we're going to take the center, which is negative 1, 2. Right? We're taking this point, and we're going to adjust the y coordinate by including this. So the coordinates for our foci are going to be negative 1, comma, 2 plus or minus the square root of 5. So just tack that on to whichever coordinate is your major axis, which is the y in this case. In terms of plotting them, you're just making an adjustment from your center. You're going plus or minus the square root of 5, which means we're going up a little bit more than 2 and down a little bit more than 2 in each direction on that major axis. There is one more piece of information about ellipses that I do not have on these notes that I do want to talk about. So I'm going to add this to the bottom. That is the idea of eccentricity. Okay. So going back to the front page, I'm going to add this idea of eccentricity. Eccentricity is C divided by A. So that's going to be whatever you got for your number here for your foci divided by whatever you have for your vertice number. So if I was doing that on this first example, the eccentricity would be the square root of 5 divided by 3. It's just that number divided by that number. Okay. What does the eccentricity tell you? The eccentricity tells you how circular or how stretched out that ellipse is. Okay. So if the eccentricity is closer to 0, then that means that we're going to have a more circular ellipse. If E is closer to 1, so will always be a number between 0 and 1, then that's going to be more elongated. It's going to look more stretched out. Okay, so that is our idea of eccentricity. I do have a separate video all about that, which will still be linked. You can watch that even though you may not have the notes for that. But that's the short version of what eccentricity is. Okay, so that's it on ellipses. Next time we'll talk about hyperbolas.